And now we come to our generalized linear functional. The linear functional with degree 1 means the f is degrees 1, not f2, f squared or f3. And the linear functional from 0 to 1, because we first investigate the region is from 0 to infinity. We restrict it to 0 to 1, and then we extend it. First, we know this L1 node can smaller than the F2 node. So we can use the property to differentiate the characteristic function, and we can know the mean and variance. When we construct the mean and variance, we can try to use the mean and variance to construct the R1 space and R1 1 space and R1 minus 1 space. It's like the Gelfand triple. Yes. And when R1 can have this property, we know the triple is like this. So we have the P prime lambda can live in the R1 minus 1. So we can means the P prime lambda is defined on a Hilbert space R1 minus 1. So we can establish the triple. And the most difficult in my research is how to renormalize the P prime lambda's polynomial, because we use the Poisson-Charlier polynomial, and we can check the P1 and P2. The Pn, if we put the n is 1, P1 and P2 will orthogonal to each other, and P3 and P4, all the Poisson-Charlier polynomial will orthogonal to each other. And we use it to try to, like the S transform, to do the orthogonalize. So we can use it to renormalize the P prime lambda's polynomial. And the generating function of the Poisson-Charlier polynomial is like this. But now we not yet to use the characteristic. Maybe in the future we will use the generating function to investigate it. And next theory, we also know some property of P prime lambda and where he lives in. So we can know that there exists a generalized stochastic system. It's not an ordinary function of lambda. And above the C characteristic function, which defines a generalized system that has an independence value at every point lambda, the lambda intensity. We can define a linear system. Why it's linear system? Because we call the linear process the linear system, because the process is focused on T. So we change the term process to system to become linear system. But actually, you can realize it. We call linear system actually is linear process. And because the CF can be expressed like this. So when F is in the space, the intersection L1 and L2, we can get the two moments term like this, or second moment term like this. So we first restrict the integral from 0 to infinity to 0 to 1. And then after that, we will extend it. So now come to our last proposition. The last proposition, we think all the moments will exist. And the first moment will be like this. And the second moment will also be this term. So maybe in the future, we can try to construction the higher poly